Good morning everybody. In this session we will be discussing about some basics of exercise physiology. We will be discussing about the second wind also in this session. This session we will be discussing about the different energy system, a brief idea about the different energy systems of the body. We will be discussing about what is lactate threshold and oxygen deficit and depths. Again, we will be the next thing we are going to discuss about here is the regarding aerobic and aerobic exercise. What is Vo2 Max and which are the different types of skeletal muscles, which are the characteristic of skeletal muscle, what is conditioning, what is deconditioning, which and what is meant by endurance and what is second wind. Now, energy systems. There are three types of energy systems are seen at the body. These are ATP Pcr system or ATP Creatine Phosphate system. Second system is the lactic acid system and third one is the aerobic system. ATP Pcr system, it is also called immediate system. It's a lactic system. Lactate won't be produced. And it is also called creatine phosphate system or phosphogen system. The second system, energy system, is the lactic acid system. It is the anaerobic glycolysis system. Here glycolysis occurs, but it's anaerobic glycolysis. And it's also called lactic acid system because end product of this system is that is accumulation of lactic acid. There is accumulation of lactic acid may be seen at this by this system. The third one, the third system is the anaerobic system. That is, here there is usage of oxygen. This is called aerobic system. It is called aerobic glycolysis. Now, if an activity which lasting less than 10 seconds, the ATP Pcr system or ATP creatine phosphate system will be used. That is, if a very short movements, a very fast and short movement, the system used will be ATP Pcr system or ATP creatine phosphate system for up to a few seconds, even maybe up to 10 seconds. Now, after this activity, after this 10 seconds, next system work is the lactic acid system or anaerobic glycolysis system. End product of this anaerobic glycolysis system is the lactic acid. So, this system lasts for up to 30 to 40 seconds. So, this is the second system lactic acid system. Now, after this 30 seconds, there is aerobic system occurs. Aerobic system starts its action. That is, after this anaerobic systems, the aerobic system comes into function, and this is called aerobic glycolysis system. The energy ATP production is through aerobic glycolysis. Now, lactate threshold. So, lactic acid we already discussed. There is a system called the lactic acid system, or there is a lactic acid system or a short term system. So, that is the anaerobic glycolysis occurs, and there is end product is a lactic acid. So, once we are using the lactic acid, and once there is end product is formed called lactic acid, and when this lactic acid has to be removed from the body, or lactic acid has to be, and if the lactic acids are level, if the level of lactic acid is higher than body's ability to remove it, so then it is known that is known as lactate threshold. Now, so there is a coordinate activity of all these systems. Now, first of all, there is immediate system or ATP Pcr system. Then there is the glycolysis, anaerobic glycolysis system or lactic acid system works, and these are anaerobic systems. And after that, after 40 seconds or 30 seconds, so the aerobic system works. up to the starting of the aerobic system, there won't be consumption of oxygen. So the anaerobic system works. Oxygen deficit represents the difference between the total oxygen consumed during the exercise. An amount that would have been consumed has a steady rate of aerobic metabolism occurs immediately when the exercise begins. So this is the oxygen deficit is the amount, how much is the anaerobic system, it is how much the anaerobic system worked. So it is the difference between if there is a steady rate of oxygen usage, or if a steady rate of any aerobic metabolism starts at the beginning of the exercise, and the difference between the total oxygen actually consumed. This difference is known as oxygen deficit. There is another term called oxygen debt usually used. This is also called this is the extra volume, this is the additional oxygen that must be taken into the body after a vigorous exercise to restore or to restore all the system to their normal state. This is called oxygen debt. Now another term commonly comes is the aerobic exercise. Aerobic exercise means it refers to the exercise that is with moderate intensity undertaken for a long duration, where there is usage of oxygen is there. This type of exercise is called aerobic exercise. The exercise will be of moderate intensity and it is for a long duration. Example is running, swimming, jogging, walking, stair climbing, etc. According to American College of Sports Medicine, any activity aerobic exercise they define aerobic exercise as any activity that uses large muscle groups which can be maintained continuously and in a rhythmic nature. These are called aerobic exercise. Aerobic means use of oxygen. So aerobic exercise are the exercise which is done by the usage of oxygen, especially the glycolysis, the aerobic glycolysis occurs, and these are exercise of moderate intensity for a longer duration. Example, running, swimming, jogging, walking, stair climbing, etc. are considered as aerobic exercise. So what are the benefits of aerobic exercise? It increases the maximal oxygen consumption. It improves the cardiovascular and cardiorespiratory functions. So aerobic exercise improves cardiovascular and cardiorespiratory functions. It increases the maximal cardiac output. It increases the blood volume and oxygen carrying capacity. It decreases the workload of heart for a given submaximal exercise intensity. So it increases the maximal cardiac output, it increases the blood volume and decreases the workload of heart. It increases the blood supply to the muscles and ability to use the oxygen. So blood supply to the muscles will be increased, and ability to the use of oxygen by the muscles also increases by aerobic exercise. It lowers the heart rate and BP at any level of submaximal exercise and increases the threshold of lactic acid accumulation. So as the threshold of lactic acid accumulation has increased, so the lactic acid, so it won't cause fatigue. So there is less chance of fatigue as the lactic acid accumulation is increased. So then it causes a lower resting systolic and diastolic BP with people with high BP. So aerobic exercise has to be recommended for peoples with high BP. And it increases HDL cholesterol, it decreases blood triglycerides, and it decreases the body fat and improved weight control. So decreases the body fat. Aerobic exercise can decrease the body fat and increase the weight control, and it improves the glucose tolerance and decrease the insulin resistance. Another term usually comes while we go through the exercise physiology books or exercise physiology is the Vo2 Max. VO2 max can be defined as the maximum amount of oxygen consumed per minute when an individual has reached a maximal effort. That is, it is usually expressed in milliliter per kilogram per minute. Now, VO2 max is equal to cardiac output into arteriovenous difference. Cardiac output is equal to heart rate into stroke volume. Arteriovenous difference means it is the difference between the arterial and venous oxygen level. So, VO2 max is the cardiac output into arteriovenous difference. Now, the importance of VO2 max. VO2 max is an index for the maximal cardiac, cardiovascular and pulmonary function. It is the single most useful measurement to characterize the functional capacity of the oxygen transport system and is a limiting factor in endurance performance. Now, which are the factors which determine VO2 max? There are some peripheral factors and central factors are there. Peripheral factors include muscle blood flow, capillary density, oxygen diffusion, oxygen extraction, hemoglobin oxygen affinity and muscle fiber profiles. These are the peripheral factors which determines the VO2 max. There are some central factors like cardiac output, arterial pressure, hemoglobin, ventilation, oxygen diffusion and alveolar ventilation perfusion ratio. These are the some central factors which determines the VO2 max. Now, there are some factors which affecting the VO2 max. It includes the gender, genetics, body composition, muscle mass, age, any pathologies, any diseases. There are some extrinsic factors also like activity level of the person and time of the day of activity, whether it is the morning, whether it is the evening, whether it is the night. Next is sleep deprivation. Dietary intake also affects the VO2 max. Nutritional status of the person and environment also affect the VO2 max. Once we see age, as the age increases, VO2 max keeps on decreasing in a same manner even in athlete, even in sedentary population, even in moderately active population. As the age increases, the VO2 max keeps on decreasing. And once we see the gender, males is having VO2 max more, but still as the age increases, VO2 max keeps on decreasing. Women is having less VO2 max. Now, in case of any injury, there may be chance of bed rest, and bed rest also affect the VO2 max. As the bed rest, the days of the bed rest increases, VO2 max keeps on decreasing. Next common term usually comes is during exercise physiology is the respiratory exchange ratio. Respiratory exchange ratio is the ratio between the carbon dioxide expired divided by the oxygen consumed. It is measured by gas exchanged at the mouth. That is ratio of carbon dioxide expired and oxygen consumed. Respiratory quotient means that it is the ratio of carbon dioxide produced by the cellular metabolism to oxygen used by the tissues. So, it is the measurement are made at the cellular level. Next is regarding the skeletal muscle fiber type. Usually, we already discussed regarding the structure of the muscle, there are usually two different types of muscle fibers are present in the body. These are the skeletal muscle fibers are present in the body. These are fast twitch muscle and slow twitch muscle. Slow twitch muscles are also called type 1 muscles, and fast twitch muscles are called type 2 muscles. Again, fast twitch muscles are two different types, type 2A and type 2B. So, all these muscles are having different regarding aerobic capacity. For example, type 1A is having a high aerobic capacity. At the same time, the myoglobin content also more in type 1A, and the color of type 1A and type 2A is red, but type 2B is white. So, this is white muscle, and color, the red is the type 1A and type 2A are red in color. Now, the fatigue resistance is high in type 1A and it is low in type 2B. Then glycolytic capacity is and glycogen content is low in type 1A, it is high in type 2B. And triglyceride content is high in type 1A and low in type 2B. And myosin heavy chain is, there is difference in the myosin heavy chain also in all these type of muscles. So, there are three different types of muscle fiber. We can broadly classify into it as slow twitch and fast twitch muscle fibers. Slow twitch muscle fibers are type 1A fibers. Fast twitch are two types again, type 2A and type 2B. Now, we used to hear the term, another term we used to hear in exercise physiology is the conditioning. Conditioning means it is the augmentation of energy capacity of the muscle by means of exercise program. It is nothing but we are training the person or we are training the muscles by using different types of exercise program. This is called conditioning. Now, there are different principles of conditioning. For example, there are around lots of principles regarding conditioning. Some principles are specificity principle, adaptation principle, overload principle, reversibility or detraining principle. That is, once we are giving conditioning, it may be a strengthening exercise, it may be a flexibility exercise, it may be a mobility exercise, it may be a stretching techniques, it may be any other exercise. We can incorporate n number of exercises, different types of exercise. What we need exactly depends upon what type of conditioning we need. So, conditioning means it is the augmentation of energy capacity of the muscles by means of exercise. Now, the principles are the specificity principle, adaptation principle, overload principle, reversibility or detraining principle. Specificity principle means if you are giving a training, if you are giving a conditioning program, it should be specific. Then only, for example, a mobility exercise cannot give you a strength. A strengthening exercise cannot give you mobility. So, that is called specificity exercise. For example, if you need to improve the range of motion, you have to go specifically the range of motion exercise. If you need the flexibility of the muscle, a strengthening program cannot help you to improve the flexibility of the muscle. You have to go for stretching or the exercise which is specific to the flexibility to improve the flexibility. And for example, if you want to improve your strength, if you want to improve the strength of a muscle, you have to go for the strengthening program. There is no other way. Stretching does not improve your strength. This is known as specificity principle. Second principle is the adaptation principle. Whenever you are giving a stimulus, there will be adaptive changes will be there. This is called adaptation principle. Now, overload principle. Once you are giving a load, there will be adaptation, there will be changes, there will be response. According to the response, there will be changes. And if you are keeping the same stimulus for a long duration of time, there won't be much changes. In order to get more changes, you have to overload. For example, if you are giving a strengthening exercise, strengthening with 2 kg of weight, and if there will be a response there will be a changes or adaptation from the muscles. Now, if you are giving the same 2 kg, there won't be more changes. So, in order to increase more strength, you have to increase the weight, you have to overload, then only there will be change. This is called overload principle. Now, reversibility or detraining principle. For example, if you are training for a long duration of time and if you are stopping your training, there is chance of deconditioning or detraining or reverse. This is called reversibility. So, this reversibility has to be avoided by a proper training program. For example, if you are training for a long period of time and you are taken a rest, you got an injury or you are in prolonged bed rest. So, whatever the training we have done, its effect will go off. So, once if there is a prolonged bed rest, all the effect of training will go off. This condition is called deconditioning. So, there will be decrease in the muscle mass, there will be decrease in the strength, there will be decrease in the cardiovascular function, there will be decrease in the total blood volume, there will be decrease in the plasma volume, there will be decrease in the heart volume, there will be decrease in the orthostatic tolerance, there will be decrease in the exercise tolerance, and there will be a decrease in the bone mineral density. So, whenever you are doing, if you are doing a prolonged bed rest, so this all the activity, all the effects which you have done by the conditioning will go off, and this condition this condition is known as deconditioning. Next term we used to discuss in exercise physiology is the endurance. Endurance can be defined as ability to work for a prolonged period of time, or we can define it as ability to resist fatigue. Now, once we are endurance, in common term we call its endurance as stamina. That is, there are two types of endurance are there. The first one is muscular endurance, second one is cardiovascular endurance. So, once if your muscle can work for a prolonged period of time, it's called muscular endurance, and if your cardiovascular system can do work effectively for a prolonged period of time during the aerobic exercise or during jogging, running, etc. This is called cardiovascular endurance. So, muscular endurance means it is the ability of an isolated muscle group to perform repeated contraction over a period of time. So, endurance, there are two types of endurance. Endurance is the ability to work for a prolonged period of time and ability to resist fatigue. There are two types of endurance are the muscular endurance and cardiovascular endurance. Next term usually comes in exercise physiology is the second wind. Usually, once you are doing a prolonged period of running, especially distance running, for example, marathon or road running, whatever, when the athlete become tired, he become out of breath, he suddenly find a strength and press upon its top performance with legs exertion. This is known as second wind. That is, it is a phenomenon in distance running where the athlete who is too out of breath and tired to continue suddenly find a strength and to press and goes his top performance with less exertion. This is known as second wind. Some researchers are saying that it is purely psychological. But some researchers are saying that second wind is the result of body finding the proper balance of oxygen to counterbalance building up of lactic acid in the muscle. Other researchers are claiming that the second wind are due to endorphin production. So, anyway, the second wind is the person suddenly find a strength and reaches his top performance once he is out of breath. This is called second wind, and some researchers still doubting that it's not there is no physiological changes, it's only psychological changes, and some scientists are saying that there is body find out a proper balance with oxygen to counterbalance the build up of that is lactic acid, which is the fatigue producing factor, and others claim that second wind is due to endorphin production. We have already discussed some basic terms, some basic terminologies which come across once you go through different exercise physiology books. Welcome back. In this session, we will be discussing about the energy systems of the body. Before we start the energy system, one of the most common law of thermodynamics, that is law of conservation energy. All of us know that law of conservation energy states that energy cannot be created or destroyed. Now, all energy of the muscle is provided, of the energy is provided to the muscles in the form of ATP. So, chemical reactions in the body causes ATP to break down and release energy to the muscles for work. So, energy to the muscles are provided in the form of ATP. Then ATP goes, it breakdowns and causes the release of energy for work. ATP is a molecule which contain, it's also called, it's the full terminology is, it's adenosine triphosphate. By the name itself, it contain, we can understand that it contain a molecule of adenosine and 3 phosphate molecules. ATP consists of adenosine. It's composed of, again, adenosine composed of an adenine ring and ribose sugar and 3 phosphate groups. So, that is called an adenine ring and ribose sugar forming an adenosine and 3 phosphate molecules forming triphosphate, and it is known as adenosine triphosphate or ATP. Now, ATP is it is the form of energy which is given to the muscles, and it is the energy for the muscle contraction. And it is the energy for the movement of the muscle, it's all the movements, all the energy for the muscles and muscles, for the movement of the muscles is in the, as a molecule like called ATP, and how body uses that stored ATP. Now, ATP, well, I told you there is an adenosine molecule and 3 phosphate molecule. In order to release energy, ATP has to be broken down. ATP has to be broken down to ADP and phosphate molecule, that is adenosine diphosphate and a phosphate molecule, that is ATP breakdown into ADP and P, that is phosphate or phosphate molecule. And the energy released, allows for this energy released will allow for muscle contraction. Now, how this ATP, that is once the ATP is used, the amount of energy ATP will get depleted, or the stored energy that there should be resynthesis of ATP. So, in order to resynthesis ATP, there should be some fuel. So, fuel and the fuel is from carbohydrates, fats, proteins and creatine phosphate. These fuels resynthesize ATP, resynthesize ADP back to ATP. These fuel sources resynthesize free phosphate molecule back to ATP. So, free phosphate molecule and ADP joins together and forms the ATP. Now, resynthesis of ADP back to ATP, that is first of all adenosine ADP with the help of it, we already discussed how it is getting resynthesized, that is ADP is with the help of carbohydrate, fats, proteins or creatine and phosphate, ADP attached with the phosphate molecule and gets the ATP. Now, once we are doing movements, there are different ways we does the movement. We may do the movement in a quick, powerful way, or we may do the movement in a grace coordinated way, and the movement may be a movement sustained for many hours. Now, and everything depends upon the capacity to produce energy. So, there may be the person, maybe even in sports also, there may be, once we correlate with this movement with the sports also, there will be quick and powerful movement, there will be coordinated graceful movement, there will be sustained movement for many hours. So, 3 ways human moves. Now, quick movements which last for a few seconds, there will be movements with coordinated reduced speed movement which last for a few minutes or several minutes, and there will be a reduced intensity movements which last for several hours. For each activity, the body uses different types of energy systems. Now, all these activity, if it is a fast activity, or if it is a coordinated with slow speed movement, or if it is a long lasting movement, for all these movements energy is required, and it is supplied by some energy systems of the body. Now, energy systems of the body, there are three types of energy systems. This already we discussed once we discussed the introduction, once we were doing the introduction. So, there are three types of energy systems are commonly seen in the body. These are, we can broadly classify it into as two. First of all, aerobic system and anaerobic system. Then anaerobic system is again two types of system, an immediate system and a short term system. Now, the immediate system is also called Atp Pcr system or Atp creatinine phosphate system. It is the immediate system. It is also called a lactic system mainly because the lactic acid won't be produced at this type of anaerobic activity. And it is also called creatinine phosphate system or phosphogen system. So, it is the immediate system which lasts for few seconds, 2 to 3 seconds for an abrupt speedy activity. So, the first system is the Atp Pcr system or Atp creatinine phosphate system. It is the fastest system. Second system comes into action is the lactic acid system. It is also called, it is anaerobic system. It is anaerobic again. It is also called anaerobic glycolysis system. That is, here glycolysis occurs, but it is not aerobic, it is anaerobic glycolysis. As there is anaerobic glycolysis occurs, there is production of a byproduct called lactic acid, and this may get accumulated. So, lactic acid accumulation may cause fatigue of the body. So, this lactic acid has to be removed properly, otherwise the body may get fatigued. So, because of the production of lactic acid as byproducts, the system is also called lactic acid system. And the third system is the aerobic system. It is the aerobic glycolysis. Here we use oxygen. So, this is by the glycolysis, which is exactly aerobic. There won't be production of lactic acid in this system also. So, we can broadly we can divide all the energy system into three, that is Atp Pcr system, lactic acid system and aerobic system. Now, in all these systems, the type of energy used will be ATP. The type of energy used and interplay between them depends upon the frequency, duration and intensity of the activity and fitness level of the individual, and ATP uses in all these energy systems. Now, once we see the three systems, for the activity which is lasting for 2 to 3 seconds, even maximum up to 10 seconds, the Atp Pcr system or immediate system will be used. It is for short bouts of activity. So, the first 2 to 3 seconds or even up to the 10 seconds, even the Atp Pcr system will be used. So, now after that up to 40 seconds, the lactic acid system works. That is, lactic acid, there is production of lactate will be there, and after the 40 seconds, then for an aerobic system comes into play. Now, we will go through what is Atp Pcr system. So, it is a combination of ATP and creatinine phosphate makes up this system. Now, we already discussed breakdown of ATP breakdown into ADP and phosphate for the release of energy. Now, ATP, once we uses the ATP, there is depletion of the ATP. So, this has to be resynthesized. So, ATP is converted into ADP and phosphate, and there will be release of energy. Now, ADP and phosphate must be reformed, that is, must be rebound to form the ATP for a continuous muscle action. Now, the fuel for this is creatinine phosphate. So, creatinine phosphate provide the energy for free phosphate to be reattached with the ADP molecule to form the ATP. So, that is why this is called for ATP creatinine phosphate system here the creatine phosphate is the mediator, or we can say it is the energy to recreate or to remake the ATP for the energy. So, this system provides most of the ATP during the powerful or explosive effort. However, the total amount of this creatine phosphate stored in the human body is it is very limited. So, altogether around that is the total amount of creatine phosphate stored in the human body is extremely limited. So, energy released from the breaking down of ATP also required to resynthesize the creatine phosphate. Nevertheless, this process will be carried out when the human body is in the recovery phase, and to complete the ATP Pcr system, the complete ATP Pcr system can provide around 5.7 to 6.9 kilocalories of energy, and which can maintain up to 10 seconds of maximal effort. So, this much of energy will be used before 10 seconds itself. So, ATP Pcr system can provide a very less amount of energy, but it is a very fast. So, mainly the importance of ATP Pcr system is the instant energy, instant source of energy and a fast energy to the body. The ATP Pcr system does not require oxygen in the muscles for a proper functioning. Besides, it required fuels, that is ATP and creatine phosphate, which is already stored in the muscle cells. So, the chemical reaction involved when creatine phosphate is broken down are fewer than the other two energy systems. Now, the ATP system particularly important for the high intensity, high speed activities, but it has to be completed within very few seconds. For example, for an abrupt activity like starting or jumping or throwing or a fast weight lifting, this type of activity, the ATP Pcr system will be used. So, within 10 seconds or with a period of less than 10 seconds, the maximal effort, the phosphate system is completely depleted or largely depleted. The body again, anyway the body needs again energy. The body has to reduce the intensity of activity at this point. At this point, the next energy system has to work, that is here the glycolytic, that anaerobic glycolysis system or lactic acid system comes into action and takes over the dominant part of provider of ATP. So, up to this level we were using the ATP Pcr system, but it won't, the entire ATP or entire phosphate will get depleted. So, another system has to take over the work, and this is done by lactic acid system. So, once we see the ATP Pcr system or ATP creatine phosphate system, which is highly used for high intensity jumping, throwing activities, and uses the storage of phosphocreatine or creatine phosphate to remake ATP, and creatine phosphate instantly available but runs out quickly and only maximum up to 10 seconds, usually it is 2 to 3 seconds, and if the activity lasts longer than 10 seconds, ATP must be remade by some other means, and the mean is the lactic acid system or anaerobic glycolysis system. Now, the second system just after aerobic system, the immediate system or creatine phosphate system is the anaerobic system. It is used for high intensity exercise near maximal effort. For example, if a person is running a 100-meter sprint or a 50-meter swim, this person, he uses the immediate system, then he uses the lactic acid system. Again, the lactic acid system, it's an anaerobic system, and the byproduct formed in this lactic acid system is the lactic acid. Now, this lactic acid is the byproduct of this lactic acid system, but the production of the lactic acid, accumulation of the lactic acid causes, the researchers are saying that accumulation of the lactic acid causes causes fatigue. So, lactic acid system causes fatigue also, but it provides the bulk energy for high intensity just below the maximal effort, and also when there has been insufficient time to replenish the phosphocreatinine in repeated maximal effort. During 400 meters of sprint, the phosphocreatinine system allows an explosive start. However, an anaerobic glycolysis system dominates the most powerful race. Dominates in during for example, during a 400 meters of sprint, phosphocreatinine system or the immediate system allows him for an explosive start or a faster start, but the anaerobic glycolytic system or lactic acid system dominate for the next that is dominate the most of the races. The lactic acid system break down glucose in the absence of oxygen, because we know that it's an anaerobic system to produce the limited supply for energy for the resynthesis of ATP. ATP will be resynthesized and supplied as energy, and this partial because the breakdown is in the absence of oxygen. This absence of, if the breakdown occurs in the absence of oxygen, it causes the production of lactic acid and accumulation of lactic acid. Now, once the lactic acid is accumulated in the muscle, the contraction of the muscle will get inhibited. Now, up to a level, body can tolerate the level of increasing level of lactic acid, until if the level is higher than that ability to remove it is called lactate threshold. When lactic acid levels are greater than its body's ability to remove. So, when the lactic athletes passes this threshold, they should slow down. For example, for a player, a trained athlete may not hit the threshold until near finish. An unfit, for example, a runner who won't fit this threshold, who won't hit this threshold until he finishes his finishing point. But an unfit player, he may hit the threshold much earlier and he may get fatigued. So, proper training is also important. So, athlete will slow down its activity once it reaches the lactate threshold, because there will be chance of fatigue. There will be fatigue because lactate accumulation inhibit the muscle contraction and the muscle get fatigued. So, we already discussed regarding the lactic acid system. Body uses stored fuel glycogen to remake, that is, but it is in the absence of oxygen, and it causes so what is happening is that there will be byproducts called lactate, and hydrogen ion also released, and it inhibits the muscle contraction. So, if the work is more than that, there may be production of lactic acid and it may cause produce fatigue. So, the body has to switch into another system where the lactate is not produced, and the system is called aerobic system. Aerobic system is used for the activities that require a more sustained and plentiful supply of energy. This system uses carbohydrate, fats and proteins, sometimes protein in the presence of oxygen. This produces large amount of energy for ATP resynthesis. So, these food products, especially the carbohydrate foods, especially the carbohydrates, fats and sometimes proteins combine with oxygen and produces energy, and byproducts of carbon dioxide and water which can easily be removed. So, it is a very sufficient system because there is no production of lactate, and the byproducts of this system is carbon dioxide and water. This can be easily removed. So, it is one of the most efficient system. So, during rest, fats are the primary fuel during exercise. Carbohydrates are the primary fuel, depends upon duration and intensity of exercise. For example, submaximal activities of low intensity where energy demands are very low. For example, a lawn ball, slow walking, fats provide the major fuel. But submaximal or maximal activity with higher intensity, for example, running, swimming, intense team sports, etc., carbohydrates are major fuel. So the fuel is different in the aerobic system. We will go back to the aerobic system again. It is the system where we uses oxygen, that is aerobic glycolysis occurs, and the byproduct is usually oxygen, carbon dioxide and water. So this can be not like lactate, or this can be easily removed. Carbon dioxide and water can be easily removed from the body. So it is one of the most efficient energy system, and the energy used for this in this system depends upon the fuel used for this system is usually carbohydrates and fats and sometimes proteins, and depends upon the activity, intensity of activity and duration of the activity. It depends on, for example, which fuel is used varies. If it is a submaximal activities like slow ball, or if it is a submaximal activity like slow walking or a lawn ball, etc., in this case the energy used will be fat. Fat is the major fuel source. But in the activity like maximal or submaximal activity of high intensity like running, swimming or intense team sports, carbohydrates are the major fuels. Now, but as it is one of the most efficient system, but there is some demerits. The main demerit of this system is it produces energy very slowly. It is a much slower energy production than an aerobic system. And once the person starts once the person starts usage of aerobic system, after 2 to 5 minutes, the individual reaches a stage called a steady state. This is when the respiratory system increased oxygen intake meet the activity of oxygen demands. So oxygen intake will meet, it reaches in an equilibrium with the oxygen demands, and aerobic production of ATP and then plateaus with the required play rate, and this position is called steady state, and it is we can understand by it is the state where when the breathing becomes steady. So this point is called steady state. So if a person who can reach the steady state fast, so he will be using a less amount of anaerobic system, so he won't get fatigued fast. So once we see aerobic system, it is used in longer submaximal activities like swimming, running, jogging, cycling, etc. And there are plenty of oxygen is available for the production of ATP, and the carbon dioxide is all byproducts like carbon dioxide and water will be removed. So there won't be any accumulation. So it does not even accumulate. There won't be any accumulation of lactic acid. So this is considered as one of the most efficient system. Now, there is another term called oxygen deficit. Oxygen deficit is, I told you that there will be a steady state of oxygen consumption will be there. Now, this steady state of oxygen consumption reaches after 2 to 5 seconds. Up to this point, up to this steady state of oxygen, up to this steady state, anaerobic system will be also will be used. So oxygen deficit can be defined as it represents the difference between the total oxygen actually consumed during exercise and amount that would have been consumed had a steady rate of aerobic metabolism occurred immediately when the exercise begins. Usually the steady rate of oxygen consumption or steady rate of oxygen or steady rate of aerobic metabolism starts after 2 to 5 minutes of exercise. So it is the state. So up to this steady state level, the oxygen consumed, the energy consumed, or the energy system used is the anaerobic system. So once the steady state reaches, the system used will be a aerobic system. So this oxygen deficit is the actual measure of how much anaerobic energy used by the system. So this is called oxygen deficit. Now what will be the oxygen deficit? What will be the difference in oxygen deficit in trained and untrained athlete? Usually the person the steady rate will be similar value. The similar values of steady rate oxygen uptake will be there. But a trained person who is training regularly reaches the steady rate faster than a person with less trained. That is, trained person reaches the steady rate faster than an untrained person. So he will be having less oxygen deficit. So that means that he uses the anaerobic system less and uses aerobic system more. So great total of oxygen consumed, there will be more oxygen consumed and less anaerobic system energy transfer in trained athlete. So that's why trained athlete, he uses less anaerobic system, so less accumulation of lactic acid and less fatigue will be there in case of a trained athlete. And this adaptation trigger an earlier aerobic ATP production with lactate formation in trained individual. So, but in case of an untrained person, this oxygen, that is oxygen deficit will be more. He reaches the steady state of oxygen, the steady state bit slowly or bit later. So it causes more usage of anaerobic system, especially the lactic acid system, which causes the accumulation of the lactic acid, and this causes a fatigue. So lactate formation. So that is the difference between the oxygen deficit. Oxygen deficit of a untrained individual will be more, and oxygen deficit of a trained individual will be less. Now another term usually discuss, once we discuss the energy system, is the oxygen depth. Oxygen depth is the oxygen taken used after a vigorous exercise. That is, in the additional oxygen that must be taken into the body after vigorous exercise to restore all the system to their normal state is called oxygen depth. That is, the oxygen used after the extra oxygen used after a vigorous exercise is called an oxygen depth. Now, what are the causes for excess post-exercise oxygen consumption after an AV exercise? The first thing is that we used ATP for the production of energy. Now, this ATP has to be resynthesized, and we used the creatine phosphate in the immediate system. This creatine phosphate also has to be resynthesized. So this oxygen will be used for especially this resynthesis. Now, resynthesis of blood lactate to glycogen so has to be done through, the name of the cycle is called Cori cycle. So we use oxygen will be used for this purpose also. There is oxidation of blood lactate in the energy metabolism. Then there should be restoration of oxygen in the blood, tissue fluid and myoglobin. So for this purpose also oxygen will be used after exercise. Thermogenic effect of elevated core temperature, and there will thermogenic effects of hormones like catecholamine, epinephrine and norepinephrine. And there will be increased in pulmonary and circulatory dynamics and other elevated levels of physiological function. So these are the causes for the excess post-exercise oxygen consumption after heavy exercise. So in this session, we discussed about the energy systems. We discussed about the 3 different types of energy system, and ATP it is the energy for the muscles. ATP which contain adenosine, and adenosine which contain adenine ring and ribose sugar, and a triphosphate, and triphosphate, that is 3-phosphate molecule, and this energy will be used for muscle contraction and activities. So, this energy has to be restored for in the energy system. So, for this purpose, for 3 energy systems are available. These are, we already discussed, that is, these are ATP Pcr system. This is also called immediate system, where lactic acid won't be produced at this system, and this is called immediate system. It is lasts for 2 to 3 seconds. It lasts for 2 to 3 seconds and maximum up to 10 seconds. This system is called ATP Pcr system. Here creatine phosphate is the to change the remake the ATP, but it deplete the creatine phosphate deplete fast. So, the system has to be replaced by the second system, that is lactic acid system, comes into action. That is lactic acid system, it works till 30 to 40 seconds. So, but the one demerit of this system, again it is an anaerobic system, and one demerit of this system is the production of the lactate, which causes the lactate causes inhibition of the muscle activity, and it causes fatigue. So, there will be production of the lactic in the lactic acid system. There will be production of the lactic acid. So, this is the negative thing in the lactic acid system. After this 30 to 40 seconds, the aerobic system, one of the most effective system, comes into action, but it produces energy slowly when compared to other system. But the main merits of this system is regarding its byproduct. If the byproduct is not lactic acid, here aerobic glycolysis, the byproduct is the oxygen and water, which can be removed very fastly. So, it does not affect this lactic acid system, this aerobic system does not cause fatigue. So, these are the 3 different types of systems used by the 3 types of energy system used by the body. So, that is all about the energy systems. Thank you.